So same panel as previously, 45 minutes discussion roughly, and then we'll take questions in the audience. Ladies and gentlemen, a warm welcome to our Paris Space Hub. And we are going to talk on this panel about the industrial excellence serving exploration. What if technological revolutions were born in space? Indeed, today we are diving into a fascinating question that challenges our perceptions of innovation. The industrial excellence service serving exploration. One question, what if technological revolutions were actually born in space? Indeed, we often think of space as a destination for applying our best tech, but what if the inverse was true? What if the challenges and opportunities of space exploration were, in fact, the ultimate breeding ground for truly revolutionary technologies? Let's discuss this and explore with our panelists this morning. And I'm really happy to introduce Roberto Angelini.
Good morning, everybody.
Good morning. You're Engineering Director, Domain Exploration and Science at Thales Alenia Space. Next to you is Miguel Angel Molina.
Good morning, everyone.
Good morning, Miguel, GMV Space Council Chairman. And next to you is Morgane Lecasse. Good morning. Strategy and Public Affairs Director for Astroscale Space. And we're waiting for Guillaume Gaume. If you're around, Mr. Gaume, you're, of course, welcome to join. This is you. This is not you. But you can come if you want. Sorry, I can't see very well with the light. We'll start the discussion, and if Mr. Gaume comes, he can jump into the discussion whenever. Let's start with you, Morgane. Ladies first. Astroscale, leading company in space debris management and in-orbit services. I have one first question is, how can proactive internationally harmonized regulation be a driver rather than a hindrance for innovation and the emergence of new space industries, particularly in the field of in-orbit services?
Thank you very much. Yeah, we can dive right in because regulation is one of the cornerstones of the emerging market of in-orbit services. So it's really a driver for in-orbit services if you look at how we finance in-orbit services and what will be the costs. So we have three pillars. First is the technology. We need to have the tech ready. The second will be the business case. All of this will be enabled by the regulation, which means we need regulation to be operator to comply with the orbiting rules, so as not to leave their spacecraft too long in space. So maybe they do this with redundancy on the spacecraft, maybe with in-orbit services. So we've seen so many progress in the past years, specifically with the French space law, so the technical regulations of the French space law that address in-orbit services. And there's a lot of this around this, including liability. Our first mission of deorbiting, called LZD, was back in, I think, 2017. No one wanted to give a license at that time. So you could see our regulation would hinder in-orbit services. Finally, the UK gave a license, and our spacecraft flew in 2021. And now in 2025, we even have this French Space Operation Act that addresses in-orbit services. We also have rules that are going to push the need and the appetence of operator for in-orbit services, such as the FCC that mandate their operator to deorbit within 5 years. So we have to know that above a few hundred kilometers, it would take hundreds of years to come back. So either they use propulsion or they use in-orbit services if they have to comply with the regulation.
Tell us...
It's the case for the UK also.
Sorry. Do you want to jump? Sure, go ahead.
Yeah, I can add something. First, regulation is a must today.
Of course.
It's something that we need urgently because we are in a situation which is really critical. We also, what is on top of us, this space which is around us is suffering of, I will say, a sort of pandemic. We have this space debris around us which is growing, growing, and growing, and eventually one day we will not be able to launch. I am exaggerating a little bit, but not much. Not much. Then for me, first, we need it. Second, is a source of innovation, the regulation too, because what you are saying, innovation, this regulation will show us, we put on the table activities that we can do to regulate, and particularly in orbit services, for example, is something that can be developed around this new regulation, providing support for active debris removal, providing support for helping or refueling satellites, providing support for activation or recycling of satellites flying around us. The regulation is a good point, and also it will. They have something which is important to highlight is that this regulation should be something worldwide applied.
Yeah.
If we are doing this all in Europe, at the end we are probably penalizing the commercial activities in Europe in space. This is something important to be considered, to be taken into account. We need to have an agreement, global agreement, which is difficult, between all the countries. But at the end, I believe all the countries are interested to have a safe space, to have something, an area in which we can continue to work. Because if not, the Chinese will not be able to launch, the Russians will not be able to launch, the Americans or us. Then it's important, the regulation.
Of course. Yeah, great point. Precisely, Morgan, back to you. Are Astrocale's deorbiting and in-orbit servicing technologies facing some gaps or uncertainties within precisely the current international legal framework? And how is your company working to bridge these gaps, maybe?
Yeah, so I mentioned one before, which was the very beginning, just to get a license for this mission. So you can imagine how far back we're starting. And that was, like 7 years ago. The next one is the liability. Obviously, there's a lot of safety concern and security concern around getting super close to an object, because that's what we do, and docking with it. So there's all the liability around this, and it's really important that when we get the license and when we have the regulation linked to this, it's regulated and we know what we're going to do with our objects. And then there's also the regulation that are, I think what you were referring to, more like preventive. So it's really like incentivize the operator to either deorbit or to pay for in-orbit services. And that's going to come through regulation. But we have seen in other industries some mechanism as to incentivize them with money, like in the windmill industry or the nuclear power plant, where we can put performance bond in place linked to the license.
And I think we're going to welcome Nicolas Gaume. Thank you. You're our VIP guest. Welcome. How are you?
I'm fine. Hello.
Thank you for jumping into the discussion. It's great to have you here. Thank you, Morgan. One last question, maybe, unless you have something to add on that subject. No.
It's okay.
Okay. One last question before we move on around the table about sensibilization and acceptation. How is your company, Astroscale France, working to actually raise awareness among policymakers and the general public about the critical importance of space sustainability?
So we're not the only one to do it. I think you mentioned that a lot of companies, and even ESA is releasing like space debris numbers. I think for the general public, you have to go back to things that matter to them, which is satellite. And I think you were mentioning space is important for everyone, which means you can tell them very simply, if we don't do anything, if there's too much debris, too much collision, we lose access to satellite. So what do you lose in your daily life? You don't have GPS anymore, you don't have the banking system, you don't have telemedicine, you don't have Earth observation for agriculture. So it's really protecting our critical infrastructure, and that the general public can understand. So they're more and more aware about mega constellation with a certain American entrepreneur. And now I think they're more and more aware about space debris. So it's really about what's next. And even in Japan, we have what we call an orbitarium. So you're familiar with planetarium? It's the same, but for orbit. So we have a space in our in the downtown Tokyo where kids and family can come and see for themselves, the orbits and the debris. They can also see our clean room and the solution we're building. So it's really about, awareness, explaining, and then bringing forward the solution that both the policymaker and the general public can put forward.
And Miguel, you want to add something?
Very few words. On our side, at GMV side, we are supporting a lot our customers today for the development of infrastructure and capabilities in operations to not only to prevent, but more to support the monitoring of the current systems together with the current population. Then we are able to do a continuous awareness of what is happening, and then supporting the development of a catalog on which we can use for services. Main services we are providing today: collision avoidance. If there is any risk on your satellite to crash with a satellite without control or something without control in flight, we are able to say, please do a maneuver to avoid it. Then, and no, we are providing safety to our customers, and we are also avoiding that the population will grow later. This is the kind of service that we are providing today, together with support for re-entry, without control, or promoting, and together with Astroscale, which is deeply involved also in this area, promoting the in-orbit services for the future, for active debris removal, or for the supporting satellite which are in difficulties, and we can go to solve any issue on board.
Okay, before we hear Roberto and then Nicola, who just joined us, Miguel, since you have the mic, why don't you keep it? As I said, you're GMV Space Council Chairman, and GMV, just a couple of elements, has an extensive expertise in space systems, ground segments, navigation, space surveillance and tracking, and particularly they're involved in key European programs like Galileo and Copernicus. Could you maybe share briefly some specific examples of technologies or methodologies developed within your company for space missions that have subsequently led to significant breakthrough in your company?
I will highlight, to be very brief, I will highlight some activity that we are doing for space systems, developing avionics and GNC, guidance, navigation and control systems. On this we are deeply, we have a good success, and we have been, I will give you two examples. For this, we have been involved, we have been responsible for the system, the technology developed for the guidance, navigation and control of ERA, the ERA mission, which is the support for the DART mission trying to deviate the asteroid, and ESA is trying now to evaluate the performance of this deviation. Then the satellite is guided by our solution based on a very advanced system of navigation, and also we have been responsible for the navigation in the PROBA 3 mission. I think we recently, ESA has been showing the result of this mission, which is a real success. It's a very complex and technological complex activity, and for this we have been responsible on the formation flying activity, which was the critical point. Then we have a very advanced activity providing support on navigation and also autonomy. Autonomy for satellites, and autonomy that we are now injecting in the rovers. For the future rovers that we are talking about exploration, then we are going to Moon, we are going to Mars. These rovers that will be in the surface probably will use solutions developed by us in terms of autonomy and for the navigation.
Thank you. I would like to hear you, Roberto Angelini. Could you explain what is your function, what is your role within TAS today?
So good morning, everybody. My function is I'm the engineering director of domain exploration and science, and so having the privilege to guide around 500 engineers in Torino, I would like dealing with exploration of solar system, exploration of the universe. I think we are at the forefront of the technological development.
So same question as for Miguel. Can you maybe provide concrete examples of technologies that are currently developed for space exploration by TAS?
Well, these technologies are many and different. You need to be able to master each of the building blocks that can lead you to have humans living in space, to have robotic missions, and so on. So, as Miguel was saying, there are a certain number of disciplines that you have to master: GNC, rendezvous, and docking. In this moment, we are a lot focused on in-orbit servicing. We know that in-orbit servicing will enable us a whole bunch of new activities, thinking about on-orbit manufacturing. And we go back to the regulation, because I mean, there is a lot of mass already in orbit that has a value by itself because it has been launched, and being able to retrieve it and to use it. But whose mass is this? I mean, is somebody else? You cannot just go there and bring. So the regulation will come. I would like to just to explain briefly one thing, that as we go far from the Earth, so if you consider a low Earth orbit, ISS, this is still the most protected environment, and we have a lot of consolidated technology. We are not anymore at the polo time in which things were invented in space. Not yet, let's say. We will come back to this. So a lot we take things on Earth and we make them a little bit more reinforced, I would say, or better to live in space. If you go to Moon and Mars, it's something already different. So most probably you have to take what you have developed for LEO and test it on Moon and Mars. The requirements are different. I will mention just two more significant. One is radiation, and the other will be the dust that will be on the Moon and Mars. They will change a lot the environment for which simply a lot of equipments are functioning. If we go even further and we look at science, then we are at the forefront of technologies. In this moment, we are developing scientific satellites that will be used in experiments have not been invented yet, and we are discussing with scientists. So I would say that if we talk about technology in space, we can talk a lot.
Just a question for you two, and then we'll move on to you, Nicolas. But why do you both consider space today as an incubator for technological revolutions? And maybe can you illustrate why is it to you a perfect incubator for a technological revolution?
Well, I believe it's because of the challenge that we are facing in space. The activities that, for example, exploration, our missions are really complex, really resource intensive, and really costly or a high cost. Then we need to optimize as a maximum the activities that we are developing for these activities. Then it's important to develop. It's always, and this is one of the reasons why GMV is in this business, because of the technology behind. We are essentially a technological company, and we like the challenge. And the space is a place where the challenges appear every day. Then we're in a continuous innovation, in a continuous evolution of the activities that we are developing, and then also it has been important for us to transmit this technology to the real life. And we have a good example in our company with the activities that we did. You mentioned that we are active in navigation, Galileo, EGNOS. We were able to take this technology and to bring this technology to the transportation market, doing fleet management systems. Then we are today controlling satellite buses with technology that we have been developing for satellites, which is, I think, is important.
Roberto.
Yeah, I would consider two aspects. One is the technology that we have to develop on Earth to be able to fly these incredible machines that we are able to manufacture, assemble, integrate, and test. And we go back to what I was saying before. Yeah. But the most interesting part, I would say, is the technology that we are going to manufacture on orbit. So in this moment, we are working and creating a certain number of laboratories that will be devoted to perform technological research on orbit manufacturing, I was saying, investigate on scientific principle, and this will be, I think, the most interesting part, and who knows whether it's going to arrive, but I will not say anything more because I'm sure that Nicolas will have something to say about that.
Nicolas, space has always been a source of fascination for you. I've been reading about you. You followed, for example, the success of several Anglo-Saxon internet entrepreneurs like Elon Musk, Jeff Bezos, Richard Branson, and noted that these billionaires chose to build new infrastructure. So ultimately, you were convinced that there were more opportunities to be seized in creating new services. Therefore, in 2014, I think, you decided to partner with entrepreneur Emmanuel Etchepart to launch Space Cargo Unlimited. What do you do in your company?
Well, Space Cargo Unlimited is doing in-space manufacturing for Earth, as the space environment has a very particular set of characteristics that allow to create, in a variety of verticals, of industries, high-value products that are either very difficult, if not impossible, to make on Earth. So we truly believe that the next industrial revolution could happen in space.
Yeah, I was going to ask you, could you explain what is your motivation to launch products for Earth using the unique conditions of space environment?
Well, maybe let's take a few examples for the benefit of the audience. Let's start simple. You want to produce an alloy. You want to mix two materials. One is heavier than the other. So if you merge the two materials, the heavier one goes down, the lighter one goes up. You don't have a perfect alloy. You do the same thing in space, you have a much stronger alloy That's one example. Another example, you want to produce very specific set of electronic chips. To do that, you need vacuum, you need absolute zero, you need energy. Space provide that plenty. Solar panels perform better, and vacuum and absolute zero is available. It's getting even more interesting into a number of life science scenarios, because life science has also an interesting environment. Gravity is the only parameter of life that has never changed on Earth for 4.5 billion years. So when you recreate in a pressurized environment, the Earth's atmosphere, and you remove gravity, you create a number of very meaningful phenomena. There's no convection in space, so you can crystallize proteins in a much more effectively and accelerate drug development. Actually, we announced yesterday a partnership with an amazing European biotech that is going to diminish the clinical trial on Earth by up to 5 times, because using the specific set of the space environment. There are many other things around the also more forward-looking pharmaceutical projects. So all of this is making things very real, but it's been researched for more than 20 years on the International Space Station, but it never really went into an actual production at scale. And that's what our mission is, to go to the next level and make it real.
Precisely. Let's talk about Space Cargo Unlimited's latest project, Rêve 1, how do you call it? It's the first factory to float in space starting this year.
So we are flying the first component. I really want to turn to Roberto, and if I may, it's public, celebrate our partnership with Thales and Space. Honestly, you were very humble. I think that if I want to see the future of European space, if not the future of space, I go to Torino and see what the team at Thales and Space is doing in Italy. It's extremely inspiring and extremely defining. So we're building a spacecraft, which is built out of the flagship IXV project that flew about a decade ago, and dear to Roberto's heart, and we're actually building a new vehicle with our friends at Thales and Space, which will fly around late 28, 29, that's the goal. But we're really building this vehicle inside out, and we're really starting with the outcome we pursue. There's so many space projects that start with a solution that afterwards look for a problem. So we kind of thought we should start with the problem we're pursuing, how we manufacture in space for Earth. And we went from the outcome to the payload management, the payload itself, to the payload infrastructure and the vehicle supporting the payload infrastructure. So we're really very focused on that. We made the choice to go in a very different direction from our dear friends of Exploration Company and others, which is no humans on board at all, which is self-automated robotics, because humans bring a set of constraints, of extra costs that are enormous. So we're building a fully automated vehicle, and we are going to be a factory for rent. So what we're flying this year is the insert called Bento Box, which is the inside of Rêve 1 we're doing our friends at Thales. And the Bento Box you'll see about 50 meters that way in a full-scale model. We team up with a German company doing an inflatable re-entry shield named Atmos. Great company, and so we're going to be able to fly. We have 7 flights booked. First flight is actually early next year. We are fully booked for the first flight, half second, nearly half for the third. And we're going to bring a regular rhythm for all these companies I was mentioning to be able to manufacture at scale on a regular basis. Now, what we're going to fly is about 100 kilo of pressurized payload with a certain limitation in power, 100 watts, 120 to 250 liters. Thanks to the work we do with Thales and Space, we'll be able to go to a ton and about 1,200 liters. So we go from about 7 payload we fly to more than 25 thanks to the vehicle we're developing at Thales and Space. So exciting and making it commercially viable. We bring all the service that hopefully will make it work, which is really anything from making the payload effective to going through customs, having insurance. That's the promise. Today, working with space companies, we announced one of them yesterday, agencies for the post-ISS opportunities, but eventually we really want to bring pharma companies, new materials, electronic company go into that market, which we think could be as big as $10 billion a year.
So,
yes,
first flight next year, sorry.
So first flight of the first component is, yes, early 26.
And Roberto, can you tell us what was TAS's contribution to Rêve 1 and why did you think it was
They're the brain.
No. We are cooperating very well with Nicolas. We bring our expertise in building space vehicles. We know how to do them, and it's fun to work together in a very smart way and proactive way to find the best solution to fly this very interesting and challenging project as soon as we can. And I will also add one thing. These platforms will probably bring an advantage of a more commercial-oriented intellectual property right management with respect to what we saw in the ISS. If you want to do an experiment at the ISS in this moment, you have to explain everything you will have to do, whatever, which is okay for safety reasons. But this will limit somehow the investments that private would do, for example, to make some new pharmaceutical product, whatever. So I envision that with these private platforms, business will raise a lot also for this kind of differences with the past.
Nicolas, if I am not wrong, before Rêve 1, you had sent bottles of Bordeaux wine in space. Can you tell us about this?
Well, yes, I mean, going back to what Roberto was saying, we basically, actually, one thing that is very specific about Space Cargo Unlimited, the company was created 11 years ago. We received €0, 0 cents of any institutional money. We never had any agency money so far. It's changing, of course, and I'll be very grateful to the support, but the first 10 years, we're really developing on the market that is unknown, so investors were not interested, and we had to be creative. We did a pilot mission on agriculture, and we decided to do a pilot mission to develop a new variety of vine plants that would be more resilient to climate change. We actually, exciting enough, last Friday, delivered our first customer. So we flew 320 vine plants in partnership with the French research institute named INRAE and with the French space agency CNES. And we exposed these vine plants for 10 months on the space station. They were challenged by the absence of gravity, evolved. We had a sort of series of protocols that made them, and we got a new variety of vine plants emerging. It's like a boot camp because they resisted the biggest stress they could ever face, the absence of gravity. Again, this parameter that's never changed for 4.5 billion years on Earth. When you live in space with all the pressurized ISS elements, you can survive, but the absence of gravity stresses the plant up to the moment that it evolved genetically. So we brought back a new variety of vine plants, and it's roughly 12 times more resilient to pathogens like mildew. Mildew is a disease that is killing a lot of the vines, and you can't really defeat it really well. It's a mushroom. It's really hard to defeat. But our vines resist up to 12 times better. And so we grew with INRAE 1,000 of these plants out of space. It's a new variety, and we sold it. I'll get back to your questions, but what I want to point out by this, it's one example. So again, back to what I was saying, that allowed us to fly with a Cygnus, also made in Torino, to the ISS, with Dragon to the ISS. We did a suborbital mission with Blue Origin, and with that, we saw the need for a project like Rêve 1 and the bento box that you will see next door. But we also learned about what it is, and we got it to the market, which means we're the only company to date that did a privately led, privately funded project from inception to go to market. And going back to your question, to fund it, it was really hard. I put my own money, but we didn't find any funding or support. We had a lot of technical collaboration, like with CNES, that was being defining, but to be creative, we decided to revisit a tradition of Bordeaux from the 19th century that used to age bottles of wine on sea ship. And there was a way of aging bottles of wine was called Cuvée Retour des Indes. And we invented Cuvée Céleste, and we decided to put 12 bottles of wine, Bordeaux wine, of Petrus, which is a very well-known bottle of wine, on the space station. That was hard because alcohol is forbidden on the space station, and actually glass containers are also forbidden on the space station. It was actually funny enough, our first collaboration with Thales Alenia Space, because we worked together on this project, and I appreciate Roberto because it was fun in the end, but it was a nightmare all throughout.
Well, NASA basically was questioning why we needed 12 bottles and not just a small sample for experimental and scientific purposes.
Yeah.
But we did it, and just to be clear, we auctioned the bottles with Christie's, They were sold $1 million bottle, and that really helped kick off and fund the project. So there was a creative way of funding, because as an entrepreneur, you need to be creative.
Seems like it was a lot of fun, though. Back to you, Morgane. I would like to touch on, we'll open the floor to questions. I'm sure you're going to have thousands of questions for the panelists, but I have a couple more before that. Morgane, let's touch on the economic models and finance part. Could you tell us what are the major challenges in establishing viable business models for in-orbit services that could ultimately pave the way for new space and terrestrial industries? And maybe Nicolas can answer on that too.
Well, now I'm thinking to fly sake on the space station. I don't know.
Sake, yeah, why not?
Because we have a Japanese holding, but yeah. So we discussed a bit before on the regulation of space debris and the key question is really like who pay for space debris, and we were saying the regulation will help because there's a ton of junks, so there's different economic models. What we really focus on at Astroscale is to increase our competitivity, and so to decrease the price. And really the value of in-orbit services is really to decrease the risk that's posing space debris we explained at the beginning, and to augment the ROI of the company, of the operators, of all of us who operate in space. That's really why in-orbit services are, exists. And so to close this business case, of course we need regulation, but we also need good technology that enable us to be competitive. So we bring a lot of innovation, and that includes electric propulsion, new propulsion, that includes really advanced GNC like GMV is developing. It's really the cornerstone of docking to an object. So more algorithm, new docking mechanism, so we can explore not only docking by touching, but maybe from a few meters and enabling the moving of objects like this. And obviously the safety. And I think you mentioned also autonomous operation. Really, that really brings the cost down. So it's a combination of regulation that incentivizing the operator commercially to buy these services, a combination of competitivity to bring the price down and to have the technology be a routine service, just like a tow truck that we can contract when we need, when we have a debris object, when we have a defunct satellite, when we need refueling, and a combination of having this business case closed with the right license, the right mechanism in place to fund this technology.
Nicolas, what is your say as an entrepreneur?
I just want to jump back on what you said earlier when you introduced me and to what Morgane was saying. I was in the 90s, I was an internet entrepreneur, and there was this moment where an infrastructure that had been developed by the military needs and the academic needs, which was called the internet, became open to new rising opportunities and commercial opportunities. And for many years, people said, there's no business model. You can't make money out of the internet. And investment flowed, and there was really a lot of people thinking, what is it, the use? Obviously, we all know the outcome today. Our life has changed as these infrastructure became more mainstream and new opportunity rise. So I think that you need to have in mind that it already happened in other cases, and that's really what Leo is facing today.
It's a really good example because I say a lot, it's a creativity of the business case. So you find a way with the wine, but we can see it as the last value chain in space. So it's kind of crazy when you think about it. We send satellites for one-off mission. It's like a throwaway culture. So in all other industry, even aviation, which might be the closest, there's like this last value, so where you can repair spacecraft, you can refuel them, obviously, if there's a problem, and it doesn't exist yet in space. And that's really this segment of the value chain that in-orbit services want to address. But we are in space, so there's lots of technological hurdle. But as Nicolas was saying, we're really looking at it as like a new market that will be necessary not only for sustainability reason, but also for circular economy reason. And we have to be a bit futuristic with this.
There's one thing.
It's a discussion.
There was Miguel said something which I mean, the cornerstone of industrial challenges that we have with climate change is recycle, reuse, and what's the third one?
Repair.
And repair. Sorry. And honestly, when Roberto built these amazing systems, these are the three cornerstones. You need to optimize all the resources, and we should shout to the world that there would be no solar panel, no filtering mechanism that we are using so much for the future of our planet on Earth without space exploration. And it's just the bedrock of key innovation that are really key for our future humanity.
Precisely. Let's do a bit of perspective with you, Miguel, and maybe Roberto, you can jump on that too. Looking ahead, what emerging space technologies or ongoing R&D at GMV do you believe hold the greatest promise for generating the next wave of technological revolution on Earth within the next decade, maybe? Maybe, Roberto, you have your say on that too. Perspective.
Yes, I would say three. But robotics is one of them. Development in the... Robotics is one of the technologies I believe we need to push, mainly because exploration is a very good place to do it. We are going to areas we don't know at all. Then we have resilient systems that will face we don't know what. Then we need to impose some intelligence inside those systems, and this will back to the Earth, for sure. This robotics capability will be reused in industrial capabilities on Earth. Second one, I will say communications. We are today talking about the secure communication on Earth, but we need to solve also the communications in space. The laser capabilities and all the technologies will provide us this development for the future. And the last one, I will say energy. Yeah. When we are going to this exploration to any planet or whatever, we need to bring energy from Earth, or we need to produce the energy in the place, or we will need to have something which is communicating energy to us every moment. I will give you an example for this. There is an interesting project today at ESA called Solaris, which is looking for the production of solar energy using panels in space, which is much more efficient. And what is important is I am producing the energy, and then I'm transmitting the energy to the moon, to the Earth, to other satellites. And this energy can be transmitted using microwaves or laser technologies. Then I believe these 3 points could be something interesting for the future.
So robotics, communication, energy, do you agree with that, Roberto? And
well,
then we can ask
agree.
Nicola also.
Maybe to bring some variety on this. Robotics, I totally agree. Robotics will have to come with autonomy, with artificial intelligence. We already do some of these. I mean, you cannot use rovers on the surface of Mars, piloting them from Earth. There's 40 minutes delay in communications. It's not going to work. So we are already doing visual recognition and autonomous navigation to tell the rover that has to go from point A to point B, avoiding rocks and stuff like that. But this will have to be further growing. Another example I'm having on this autonomy, you know, the lunar gateway will be not habited for 11 months per year because of the cosmic radiations. This is another challenging point, by the way. So for 11 months, what are we going to do? Are we not going to do any science? Are we not going to do any maintenance? No, this is not possible. I mean, so again, there will be some sort of robotics with autonomy capable to go. And I will add also, it was mentioned energy, maybe a side topic is propulsion. If at the end we'll have to want to colonize Mars with human beings, we need to find a way to get this travel shorter. And we know nuclear propulsion or electrical nuclear propulsion or thermal nuclear propulsion will have to be absolutely necessary. And maybe one thing side to add, we need to get organized to manage all this huge amount of data that we are going to gather from all these missions. Maybe a last example, and I will give the floor. Today with the Euclid mission, we are downloading always with very limited resources. I mean, we are talking about 4 watts transferring from deep space. We are transferring petabytes of images. I've seen these images. You can zoom these pictures, petabytes of a picture, and you can always find new galaxies and new stars. So first of all, you need to find a place where to put these things. But second, we were going to back, no human being is capable to look at all these things and detect the anomalies that we want to see. So there is again the need to have artificial intelligence to scrutinize all this huge amount of data and to gather something for the scientists.
And what do we do ultimately with this huge amount of data? That's a question also. Nicolas.
Well, just because I want to bounce back. So besides Space Cargo Unlimited work and all the opportunity in space manufacturing is offering, I also have the privilege of working for Microsoft, and I'm actually running the Azure Space business, which is really related to this very topic that Roberto. We actually had a project with Thales Alenia Space, colleagues of Roberto. We put a data center with Thales Alenia Space and Microsoft on the International Space Station for the very purpose of exploring this. And the amount of opportunities that are coming out of this are pretty fascinating. And surely Microsoft has this product called Planetary Computer that is ingesting petabytes of data and making sense of it. So all the AI knowledge is really bringing ways of being able to do urban planning in ways that have never been done before, being able to have optimization of insurance costs, which are becoming more and more complex. We are working with agricultural companies to know where to plant and be able to predict the level of food you're going to have in a country out of this. So all this is actually, and I think that's one of the motto of Thales Alenia Space, by the way, is space for Earth. That is pretty fascinating. And then going back to the other topic, again, we need solutions that reduce the carbon footprint, reuse materials, and I think there's no better place than that. So everything that has been covered is really creating so many financially savvy opportunity.
Let's stop here and leave the floor to questions, because I'm sure you want to interact with our panelists. So raise your hand, introduce yourself briefly, and go ahead and ask your questions. Come on, this is a top-class panel, world-class panel here for you guys, so do not hesitate. No questions so far? Yes, sir. Let's maybe bring a mic if we have one. Yeah, there's one. Can you introduce yourself and then go ahead?
Je ne sais pas si vous m'entendez? Oui, parfait. Très bien. Donc je travaille dans l'aéronautique. Je connais un petit peu Nicolas récemment. I have one question. What can you say more about reducing cost and delays in space operations, please?
Reducing cost and?
Space operation, space cost and delays.
Cost and delays.
Please.
Who can answer that?
No cost, no.
No,
Roberto.
okay. Well, usually when we take a project, we take a commitment for the dates. Of course, it's always very difficult. The requirements are changing and so on. I will make a point to cost. We have seen cost reducing every year in the last decades. The offers that we are making, I tell you, I've been going through a huge optimization process. I'm thinking about the cost of engineering with the new tools, with the new rationalization. We are really doing the same things we were doing 20 years ago with half of the price of the things. And this is mandatory. I mean, if you don't strive for competitiveness, you are dead, okay? So here are coming a lot of new ways of working. And I will make maybe one thing, which is in the past, we were going to the best, let's say, take an example, valve producer, okay? I say, okay, you are the best valve producer in the world. I need a valve from you, but I am Thales Alenia Space, and I will tell you how you have to do your valve. And this, you can imagine, was, okay, at the end we had the valve that we wanted, but with a lot of time and a lot of money. Today is much more different. We go to the best valve producer in the world. There are a lot of excellencies, and tell you, hey, let me show what are the valves you have in-house, and let's work together to see what of these valves can fit our applications. My mandatory requirements that I cannot derogate are 1, 2, 3, but let's work together. And this changes completely the logic we had, and especially in this moment in which probably time is more important than money. Every shortcut you can take on time is bringing a value also on money that you are saving. And then that's it.
Well, only one thing, quick
ahead.
thing. Reduce costs and delay and time is nice, very nice. It's what everyone would like to have it, but without putting at risk the quality. In space, you cannot reduce the activities for validation, integration, and preparation of the systems, because if not, you are putting at risk the system at the end. Then I am not saying that we don't need to do it, but if we want to do this, we can do this in a serious way. And today, I know there are many companies working in something called industrialization of the space. They are looking for the way in which we can deploy our systems in a real loss without reducing costs, improving the supply chain, and reducing the time. But we need to have a very deeply analysis behind this, because if not, is what happens. We started with this new space concept in which we were not considering validation, for example, at all in the system that we were launching, and we have today the problem that we have today. I'm not saying the origin is only this, but there are many other components around. But if we are not doing this in a serious way, of course, we will put everything at risk. And I suppose ESA will be very happy if we say that the cost of the mission will be a half of the price that we will say at the beginning, or the price that they will considering. But if we are doing this, because if we are doing it in a safe manner. This is my only comment.
Nicola.
I certainly agree with Miguel, but I come from a world where we say better done than perfect. Better done than perfect. I come from a world where, let's put it that way, non-recurring engineering costs are evil, and you don't want them. And so I really think there's also ways, and I really like what Roberto said, is that you heard what Thales Alenia Space is doing. We work with RFA, which is a great rocket company that is using the automotive industrial complex to provide the parts that are done on millions of cars instead of doing a most expensive component, specific tailor-made for space. So I think there's definitely a lot of that. So in a nutshell, it's an ecosystem play. That's really our culture. That's why we're so excited to work with Thales Alenia Space. That's why we're working with the Atmos Space Cargo on a re-entry. We think that we are in a moment where we need to go together, change paradigm by being focused on outcome and impact instead of waiting for programs tailor-made to get things done. And I think that's a cultural change. I was at Starbase 3 weeks ago in Texas, and they're building the Starship like software. I mean, it's striking to me. There's like tens and tens of 144 meters Starship being made while the system doesn't work. And they test it, and they blow, and they learn, and they change the things they already built and build on. So it is very demanding because it's working capital and engineering cost is enormous, yet, and I don't say it's good or bad, I'm just saying that's the way they do it, and it's pretty inspiring. And I think in Europe we can find a balance between the safety demand that Miguel was referring to and the optimization of cost, because we're in a race. China and America and India and others will not wait for us. We have to have a sense of urgency. And we at Space Cargo Unlimited want to celebrate the partnership we have with Thales Alenia Space, the one we have with Atmos Space Cargo, because that's the way we make things happen together.
Thank you. Do we have another question? Were you raising your hand? Yes? Can we bring a mic? Hello, can you introduce yourself?
Hello, my name is Aina Doyle. My question for the panel is, what technology developed in space, what technology transfer, spin-out, or product directly produced in space, brought back to Earth, has the greatest potential to really transform how we live our lives every day and have the greatest impact on terrestrial industries?
Interesting question.
Well, we do say the next industrial revolution will happen in space, because we have currently some of our customers making the drugs that will really literally change. We have a company we're working with that they are building a specific drug system to deliver targeted medication instead of spreading throughout the body, because microgravity gets them a little more fluid, effective principles. We have honestly amazing processing and engineering and new materials being made that would be impossible to make on Earth. So these examples I gave earlier in the presentation, they are really meaningful and differentiating. One interesting thing also, which I did not mention, is that we have a lot of companies from the space industry coming to us to accelerate the qualification of the device. That's called IOD, IOV, as you well know, and the fact that you're able to test in real condition your equipment and get it back because we return on Earth with our craft is accelerating a lot of the infrastructure development in space. And certainly that's also quite exciting. So electronics, drugs, agriculture, and new material. That's a lot of exciting industries.
Roberto.
Yeah, if I can complement to see the global pictures, there are other initiatives in the scientific world that in this moment are purely institutional. I mean, no private will ever pay for an enormous cost of we were mentioning Euclid for the study of the dark matter. Today we have, for example, LISA. A satellite like LISA, it's a European Space Agency project, will be devoted to investigate the gravitational waves. So one thing I know for sure, somebody is going to win the Nobel Prize with the data that will be obtained by LISA, but we don't have any idea of the enormous amount of probably technological innovation that this kind of discoveries will bring. So if you want to see the global picture, on one side where, let's say, space is somehow consolidated, there is space for entrepreneurs who dare and have the courage to go there and invest, to make marvelous things on a scale economy that has not been done so far. On the other side, still institutions are good, because if you want to go at the very borders of space, then still there is the need to have some backing of the governments to do this kind of researches.
Well said. I just want to say that none of the projects I mentioned earlier and right now would have existed without agency investment in research and development. So Roberto is absolutely right to call it out.
One last question in the audience, maybe? And if not, I'm going to ask you guys and Morgan if you have one last message as a conclusion, maybe. Whoever wants to jump in.
I'll
Roberto.
start. So I will underline once again our motto, which is Space for Life. So we believe in space as the horizon for humanity to have a better life on Earth. So this is a concept which is very different from the one of Elon Musk. Elon Musk wants to leave Earth to go and fly and live on Mars. We still think that Earth is our place and we have to take care, and we know that everything we are going to do in space will have a benefit for ourselves here on Earth.
Well, let's leave Elon Musk go live on Mars if he wants to.
Where you want to.
Miguel, do you have one last message?
Well, space is important for us. It's in our lives. We have a lot of return of the investment that we are doing in space and in our life. Somebody said that we are exchanging information with more than 100 satellites every day, each of us, in navigation, communications, Earth observation. Then it's important to take care, to keep it safe, and to maintain the investment in this process.
Thank you. Morgan.
Yeah, I think just to complement this, I completely agree with Space for Life, and that's where I think we come in for sustainability. So our motto is a sustainable space for the benefit of future generation. So exactly, if you want to protect Earth with space, you also need to protect space, and you still need to have this infrastructure ready to have a sustainable space. So I think we're all working toward the same goal in different different altitude.
Nicolas?
Well, I don't think I can add anything to what Roberto, Miguel, and Morgan said. I think it's all really clear. I would say that it's also something that in Europe we maybe make a difference. I really want to echo. I think I see a lot of young entrepreneurs and a large prime like Thales Alenia Space all converging to do a space for humans and the future of humanity. So let's keep that way. I think it's the most inspiring way forward.
And it's very promising, and it's now, right? Thank you so much for a very, very interesting and relevant panel. Thank you very much. A warm, big thanks to our panelists. Thank you, ladies and
Thanks,
gentlemen.
everybody.